And also a quick note is that we are actually offering a free basement inspections for owners or individuals who are managing any basements or any structures. So if you know any person, if you yourself is managing any assets and you would want any subject matter expert to come and inspect your basement, please don't hesitate to contact us. Now, before we get started, I just wanted to share with you a couple of housekeeping items. Do note that all the audience are muted during the call. However, if you have any questions, I'd politely and respectfully ask you guys to put the questions in the Q&A tab. If you wave your mouse to the bottom of the screen, there's the chat function and there's the Q&A. You know, a lot of people are going to be talking or saying, putting some messages on the chat function. It will be hard to track the questions. So if you are able to put them in the Q&A, that will make it easier for us to address them. Moreover, if by any chance we were not able to address your specific question due to the time constraints, I'll make sure that we will get back to you with the answers of your questions. We have records and we have your contact information as well. Note that at the end of the note that, as always, we always would like to take your feedback, as it will help us to better serve you down the road with any more topics or any other presentations that we're doing. So at the end of this webinar, you're going to have a pop-up window. It's a short 5-minute survey that will basically tell us how we've performed and what you think of any upcoming webinars, how we can better assist you in these things, basically. Now, as a company, you know, one of our core operating principles is safety 24/7. And generally speaking, we always start our meetings with a safety moment. So we wanted to start this webinar with a safety moment as well. And as you guys are all aware, I'm pretty sure that everybody's updated with the coronavirus pandemic, and that's what's happening. We have been seeing a drop in the numbers in the past couple of weeks, which is pretty good. And we believe as a company that this is a joint effort by literally everybody around us in the society. And we just wanted to make sure that, you know, now some people are going back to their offices. However, we always need to make sure to keep some steps just to make sure that we're staying safe and we're keeping everybody around us safe. So these are just a couple of points that, you know, when we're going back to work, we need to always be careful of. Now, a quick introduction about our today's speaker. Today we have Mr. Bill. So Bill Hutton is actually a manager for structural technologies. He's a corrosion solutions team leader based in Dubai, and he's in charge of the United Arab Emirates. Bill is actually leading the durability related repair works for reinforced concrete structures, which includes structural concrete repairs, post-tensioning repairs, water intrusion and moisture mitigation strategies, corrosion protection and cathodic protection. As a solution builder for structural technologies, Bill delivers technology-driven turnkey solutions on an investigate, design, build basis to repair, restore, and extend the service life of the structure. Bill is an active member of the Institute of Corrosion and the National Association of Corrosion Engineers. He is a certified cathodic protection specialist and cathodic protection technologist and senior corrosion technologist. Bill has 12 years of Middle East experience protecting and repairing concrete structures. Bill, this is all yours, man.
Thanks, Karam. Yeah. Good morning, everyone. Thank you for being here with us today. Appreciate everyone's time. So I just wanted to start off with a quick introduction for those of you who may not be familiar with Structural Technologies. So Structural Technologies is a US company. We've been around for almost 50 years. We've been in the Middle East for about 12 years. Our annual revenue is more than $600 million US dollars per year, and that's repairing, strengthening, and protecting existing reinforced concrete structures, which positions us as one of the largest specialist repair contractors in the world. So we have two main parts to our company here. We have Structural Technologies, who provide engineered solutions, and they have some specialist products, for example, carbon fiber for strengthening or some impressed current cathodic protection equipment. And then we also have Structural, which is the specialist repair contractor. So together between Structural Technologies and Structural, we provide turnkey solutions to make structures stronger and last longer. So the agenda of the presentation today, we're going to go over common problems in basements, and then we're going to look at repair techniques for water intrusion, concrete repair, corrosion protection, and strengthening. So the target audience for this seminar, as Karan mentioned, is actually owners, property managers, and facility managers. And obviously you can see from the content, we have, four very extensive subjects to go through. So, we're not going to be able to have time to go into the depths and the weeds of each subject. So it's just to give you a general, overview. But of course, if you have any questions, feel free to ask them using the Q&A, or you can reach out to us at any time if you require, more in-depth discussion on anything we touched today. So we start with common problems with basements. So, in my opinion, really, most of the problems we see with basements fall into these categories. They're either related to ingress of groundwater, they're related to corrosion of steel reinforcement, they're related to maybe poor implementation of maintenance programs, or related to some kind of change in environment or change in exposure condition. So we're going to start by going into control of groundwater. So I thought I'd just start off with some, photographs so that everyone is, familiar with what we're talking about. So, unfortunately, most of the basements here do actually leak. So water can come in through MEP openings. It can come in through cracks or construction joints, or it can come through expansion joints. Interesting fact is that concrete above 24 MPa is actually watertight. But that's except at the joints, the cracks, and the honeycombs. So it's generally at the defects. Wherever you have a defect or a concrete interface, a construction joint, that's where the water can come through. So most buried structures, including basements, are constructed with a waterproofing membrane system. So this could be a bonded or unbonded system. And the idea of this, or the design intent of this system, is to prevent water from coming into a building. However, in our experience, more than 70% of these membranes seem to fail in some way or another. And then once the membrane has failed, water is like electricity, and it will just take the path of least resistance into a building. So the pathways could be, left in place form ties, could be construction joints, could be MEP openings, could be cracks, or could be porous avenues if you have poor quality concrete or honeycomb. And as Morty discussed in detail yesterday, groundwater coming into a building is one problem, but really the bigger picture is that this groundwater contains salt, which causes the steel to corrode. So I'm not going to go detailed into the mechanisms because that was discussed yesterday, but once the chlorides get into the concrete, they cause the steel to corrode. Corrosion product is very expansive, so it means it can occupy 10 times more space than the steel, so it grows on the steel, puts pressure on the cover, and can damage the concrete, which can end up, resulting in a loss of strength for the structure. So examples of groundwater control solutions include interior coatings, or coatings in general. So generally, if you're talking about basements, the water's coming in from outside. So if you have if you install a protective coating on the inside, which would be the negative side, then probably it's not going to be an effective means of water control. However, if you have, for example, a water tank in a basement where obviously the water is inside the tank, if you put a coating on inside the tank where it's on the positive side, then it can be a good method of controlling or making a structure watertight. We also have water management systems. So water management is where water is allowed to come into a structure, but it's collected, it's managed, and it's routed to a sump, and then it would be pumped out of the structure. We have pressure injection, which is extensively used as a means of groundwater control. And then we have something called electroosmotic pulse, which is a technology which uses electroosmosis, which is the movement of water in the direction of positive charge. So we'll start off by having a brief discussion on pressure injection. So we're going to talk about two basic concepts today, or means of doing pressure injection. So the first would be what we call backside or curtain grouting. So what we're doing here is we're actually drilling completely through, or we're drilling almost completely through the member. So if it's a wall, we're drilling almost to the back of the wall until we leave about 10 millimeters of concrete. We would then put a steel bar or steel rod down into that hole. We would tap it, we would fracture the concrete, and you would actually pump injection material. You pump injection material behind the structure. So the first area that you might try to inject this material is between the cavity, between the back wall and the existing waterproofing membrane. So this is really the closest you get to ever trying to reinstate the waterproofing membrane. However, sometimes also in this method, when we're doing curtain grouting, if there's extensive rupture in the membrane, or if there's no membrane present, then actually we're not trying to inject in the space or the cavity between the membrane and the structure. We're actually just trying to create we're doing grouting into the soil. So we're actually creating a cloud in the soil behind the wall or behind the construction joint or under the slab. And you can see a photograph of this in action below. So this is a project which we completed in Dira, where you can see the holes were drilled in the raft 5 millimeter center to center, and then the material is pumped underneath it until it comes out of the surrounding injection ports, and it's sealed off, and you move to the next one. Another common method of pressure injection or chemical grouting is something called interception grouting. So this is where, if you take one of the most common areas where a basement would leak is the construction joint between the slab and the vertical member. That's a better example. So we call that the kicker joint. So that's a really common place where water can come through. So what we do is we drill in at 45 degrees angle to try and intercept the midpoint of the joint, and then we would inject the material inside to completely seal the joint. Now, there's lots of different materials which can be used for pressure injection. So what it's really important to do is to ensure that you select the correct material for your application. So, I've just listed out some typical materials which could be used. It could be a polyurethane foam, polyurethane, acrylic, or epoxy, or cementitious. But really, it's important to select this material based on the exposure conditions. So whether you have a wet or dry exposure, what is the root cause? So for example, if the crack is due to movement in the wall and you inject in a rigid material, for example an epoxy, then you're preventing that movement which is required. So then probably you would induce another crack next to the one that you just sealed. So in most cases, if you have through and through cracks in walls, you would be injecting an elastomeric sealant which has some kind of flexibility. Another common entry for groundwater would be expansion joints. So here's an example of two different types of expansion joints which are showing failure. So the photograph on the left shows an expansion joint within a basement, where above this is the ground floor soffit that we're looking at. So above there is actually landscaping. So this landscaping has an irrigation system. The expansion joint or the sealant, the expansion joint system has failed. This irrigation water is coming down through the expansion joint. So here, the owner of the building or the manager of the building has installed, what I'd say is an attempt at a water management system. So they've installed a trough on the underside of the joint. So this trough will collect the water and route it down to a point where it can then be connected into a drain. So what they've done is they've solved one problem. So one problem they have is probably water coming into their structure, which causes a puddle on the floor, maybe drips on people's cars, so they become unhappy, the tenants that are unhappy. But what they've actually done is this is at the expense of sacrificing the structure. So having this water management system in place and allowing this water to continuously seep through this joint has meant that over time, even though concrete's a hard material, it's actually like a sponge. So all of this water has been absorbed into the concrete. The water evaporates, the salt is deposited behind, and that eventually causes corrosion of the steel, which you can see here. A photograph on the right-hand side shows a failed expansion joint in a slab. So wherever you have a slab on grade, which is below the water table, if you have expansion joints in that slab, then it's a real high risk area for water coming into buildings. So in terms of repair solutions for expansion joints, it's really important to make sure, all of the effort needs to be done up front in terms of engineering. So in terms of engineering, we look at different exposure conditions. Is it a wet exposure? Is it dry exposure? If it's exposed to groundwater, then retrofitting a expansion joint and repairing a leaking expansion joint becomes infinitely more complex. And especially the further down you go, the groundwater or hydrostatic pressure increases, so it becomes more complicated. You need to look at the what traffic will be going over the joint. So will it be foot traffic? Is it car? Is it heavy vehicles? And of course, design life and warranty also play a big part, as well as access. So by access, we mean, for example, if you take the previous example that we looked at, where you have the ground floor slab and the landscaping above. So, you have two options there. One would be to repair it from the bottom. One would be to repair it from the top. So if you, the best way to repair it would be at the source. So that would be to actually remove all the landscaping, remove the tiles, and actually get back down to the joint and repair it from the top. If for some reason that's not possible and you have to repair it from the bottom, then certainly it's possible, but it could end up being more complicated, and you may face some challenges along the way. In terms of different repair systems, there's lots of different repair systems available. So I just put a few examples up here. So you can see that you can have a preformed compressible gland system for a driveway, which may have like a protective aluminium or metal cover plate over the top. There's also tape systems. So tape systems could be installed on the surface of the concrete. Generally, they're bonded with an epoxy adhesive, or they could actually be embedded into the concrete. So you would actually excavate, say, 50 or 75 millimeters down and put the tape system in, and then put a grout material over the top, obviously making sure that you have that movement available in the middle. Or you can have other gland systems which are actually embedded into the concrete. So they're actually embedded either side of the joint, and they'd be secured down with a cementitious material. Or where you have groundwater involved, normally you would require some kind of injection. So this could be, like we discussed before, it could be chemical grouting of the joint itself. It could be chemical grouting of the soil behind the joint. It could be a combination of both, and it could, the complete system could be a combination of injection plus some kind of gland plus, a tape system on the top, depending on how many lines of defense you require, and also depending on the specific site conditions. So another something else to take into consideration is that it's not always just the joint itself, which needs, as in the space between the two members, which needs to be repaired. Sometimes if that joint has been leaking for a while, then the surrounding concrete may be damaged. So you would need to carry out concrete repairs of the actual damaged concrete. And also, if you're an owner who wants to have a long-term durable solution, then maybe you need to include some corrosion control at the same time as well. So both concrete repair and corrosion control will be covered in later sections of this presentation. So water management. So the idea of water management is that water is actually allowed to come into a structure. It's collected and routed to either a drain, or it's routed to a sump where it could then be pumped out. So you're allowing water to come into a structure, but you're managing it. Now, the risk in this region is that the water, as we discussed yesterday, or groundwater, has an extremely high salt content. So wherever you are allowing this water to come in, if it's in contact with the concrete, then it may be, it it could lead to a durability related problem. So really you should carefully consider whether water management should be or is required or not. And if it is required and you're looking for a long-term solution, then possibly you need to include some corrosion control as well, such as cathodic protection. Now we'll go on to concrete repair. So for concrete repair, what are we talking about? It could be, so this is basically where the steel has started to corrode, the rust is formed on the steel, it's expansive, causes the concrete to spoil and pop off. So it could be repair of spoiling concrete on a wall, it could be repair of a cracked beam, or it could be repair of a concrete slab. So I was thinking, from an owner's perspective, if I was an owner, what would be my objectives for a concrete repair? So these are, 5 points that I decided would be important for me. So first, I think is, ensuring the safety of the structure, along with ensuring the safety of the traveling public. So a lot of these basements are used by, people park their cars. So there's vehicular traffic, there's foot traffic. So after people have parked their cars, or once they're walking to their car, they're walking from lift lobbies to their car. There's a risk of this, concrete that could fall down, could injure someone. Also, we're looking to prevent further deterioration. So also making reference to the law of fives, which Morty discussed in yesterday's webinar. And that is that durability problems, there's not a linear increase, it's an exponential increase in cost and complexity. So if your structure requires repair and you delay those repairs, then there's, an exponential increase in cost and complexity. And I think all owners, they want durable repairs and they want to ensure that they get the best value. So for every single dirham you invest in repairing your building, you want to make sure that dirham is well spent. And really, one of the objectives is to make sure we prevent a requirement to repair the repair. So we see this day in, day out, and that is repairs which are not executed properly, and that may be because, the owner didn't go through the investigation stage to really understand the root cause, or maybe the concrete repairs were not carried out to a sufficient standard. So this photograph on the right-hand side is a typical daily occurrence that we see. So we can see that this area has been repaired. You can tell it's been repaired because you can see the paint. There's a patch around where the deck coating has been repaired. This area in the middle looks like it was a patch where there was an attempt at the repair, but obviously it's not a durable, long-lasting repair, and it's failed. So now we're just going to go through some basic steps of a conventional concrete repair that you as owners, whenever you're having repairs carried out in your structure, you can check that these basic steps are being carried out, and they should help you should help fulfill your objectives. So first would be determining a suitable repair geometry. So if you have delaminations as shown on the left, if you actually just sound those out with a hammer and follow the exact, geometry of the delaminations, then you may end up with a fairly complex shape like we see in the middle. Now, the challenge is that if you repair in that complex shape, you have a lot of inclined corners, and there probably will be a slightly different thermal coefficient of expansion between the repair material and the native concrete. So if they're expanding and contracting at slightly different rates, then it means that you can actually, if you have a complex shape, then you're more likely to have cracks in your repair. And obviously wherever you have cracks, the steel is exposed and your repair may fail. So it would be better to go for a simple geometry with as little corners as possible. Something else which is extremely important is to make sure that when you're removing the concrete, so when you're excavating the concrete, you need to not only remove the concrete which is delaminated or spoiled, but you need to extend that chipping until you reach a length of clean steel. And the reason for that is that if you only remove the loose concrete and you leave steel in place, which already has corrosion product on it, which would mean that the concrete's already contaminated, then around the outside of that repair, you're definitely going to see a premature failure. Other basic steps required for concrete repair is to make sure you remove or excavate concrete behind the steel. So typically 25 millimeters below the steel should be chipped out. A simple, another way to put it is a gloved hand. So if you have your correct, personal protect your PPE on, if you have a glove, you should be able to, put your hand underneath the steel. And the reason for that is two things. One is that you make sure that you remove all of the contaminated concrete around the steel. So this steel is probably corroded because it's either contaminated by carbonation or by chloride. So it's important to remove all that contamination. And also enables you to remove any of the non-tightly bonded rust. So the non-tightly bonded rust is typically removed by some means of abrasive blasting. Once the rust is removed, you can then take a caliper. You can measure the cross-section loss. Typically, rule of thumb is if you have cross-section loss of between 10 to 20%, then you should engage a design professional. So you should engage an engineer, and they will help you determine, or they will determine, how much supplementary steel needs to be added. And the reason why we say supplementary steel, and that's because it's very rare that you would actually remove steel from a structure. You always just add in additional steel. Obviously, whenever you're adding in additional steel, it's important that you get that sufficient development length. So that's the overlap between the new bar and the old bar. So if there's not sufficient development length, then you may need to actually drill in an epoxy anchor in some dowels to provide that development length. And then also it's important that you actually have a saw cut, typically 10 to 12 millimeters around the top of the repair area, and that prevents any feathered edges. So it means that you have a good secure bond at the top of your repair. And then sometimes, this should also be roughened just to make sure you get that good lock and key. In terms of surface profile, so what we're looking for in a concrete repair is monolithic composite action. So to get that monolithic composite action, we need to make sure we have a roughened surface on the native concrete. So we would chip and provide typically a 6 to 8 millimeter amplitude. We also want to provide a open pore substrate. So that means that, as we said before, concrete is like a sponge. It has all these pores. So we need to make sure that those pores are open so that when you repair material comes in, it's accepted by the native concrete. And then also you would need to, sometimes you do actually need to have vertical dowels in or horizontal dowels if it's for a wall to enable for sufficient shear transfer. So QA/QC always plays a key part in all repairs. So there's QA/QC, along every step of the way. But at the end of the repair, once it's finished, often a test which is done is called a pull-off test. So that's where you're actually checking the bond strength between the repair material and the native concrete. So here you would actually epoxy anchor a dolly onto the surface of the concrete. Sorry, you would actually core down through the repair into the existing structure. Then you epoxy anchor a dolly on top, and then you would pull that off. And you want to check that the strength required to break the concrete is higher than the strength required by your design. So as a rule of thumb, it's typically maybe 1.4 MPa. It's also important to make sure that you have correct means and methods for concrete placement. So there's lots of different ways that concrete can be placed, advantages and disadvantages of each method. Some methods are, for example, dry hand pack. Really, it's only good for shallow or cosmetic repairs. If you have any steel exposed, it's very difficult to have correct compaction behind that steel. If you have large overhead repairs or you're enlarging a member, then probably you need to use a technology such as form and pump, which is where the concrete's actually pumped in under pressure. So it's all just about QA/QC and making sure that whatever means and methods are being used to repair your structures are correct, and they've been selected based on the specific requirements of your structure. Someone someone said this the other day actually, and that was that, there's three things in life which are guaranteed. So first one is death, second one is taxes, and the third is that concrete will crack. So unfortunately, yes, concrete will crack. If your concrete has cracked, then where that steel is passing through the crack, there is no protection. So if the cracks are not repaired properly, then what starts as a crack can quite quickly lead into a durability problem, which can then lead into, even a structural failure, even a failure of a particular part of a structure. So one very simple way of repairing cracks is what we call route and seal. So this is just where you simply route out the crack and you seal it, and it basically provides a barrier so it prevents water and chlorides and carbon dioxide for carbonation getting to the steel. Probably, it can't be used if you have a structural crack. So if you have a structural crack, you need to do a proper structural repair. But a lot of these cracks are due to thermal expansion contraction. So, it enables that movement or allows that movement to be there. But I would, definitely advise to owners is if you have cracks in your structure, then you should get them assessed. And, a lot of the time you can get cracks repaired for a fairly nominal amount, but if you leave them unrepaired, then it can lead to very expensive, complex, complicated repairs further down the line. So now we're going to talk a little bit about long-term corrosion protection or corrosion control. So what this diagram here shows is it's a schematic of a concrete repair. So you can see the darker area in the middle is the localized repair, and the lighter area around the outside is the native concrete. So that's the concrete which has not been repaired. So we assume that this concrete repair was required because the concrete became contaminated with chlorides or carbon dioxide or carbonation. So we removed all of the damaged concrete, we cleaned the steel, we added steel, we cast it back, we did a pull-off test, everything's okay. This steel now is good for, say, 10 years. In the area you've repaired, you should face no problems. However, the reason why it corroded in the first place, the reason why the concrete spoiled was because the steel corroded, and the reason why the steel corroded is because the concrete was contaminated with either chlorides or carbonation. So, for example, if you leave those chlorides or carbonated concrete in place around the outside of the patch, then you can end up with failure of, around the perimeter of the patch. So for some owners, they only have, say, for access constraints or budget constraints, they can only do patch repairs. So they understand that every 2 to 5 years, they're going to have to come in and do these repairs, which means that, you may have additional disruption, and it would increase the overall, service life cost of your buildings. So some owners, they want to explore durable long-term solutions. So we work with a lot of owners to provide long-term corrosion control solutions. So these are generally selected based on the service life that's required, whether there's any access constraints. For example, if you have a paid parking which is always full, then sometimes it's very challenging to shut down the parking for a long period of time. Also, there's sometimes constructability or budget challenges. So if you are looking for long-term solutions, then they can include, for example, removal of contaminated concrete, could be surface sealers and membranes, or could be corrosion inhibitors or cathodic protection. So we're going to go through a couple of these technologies now, or repair solutions. So first, it was going to be removal and replacement of contaminated concrete. So yes, it's definitely a long-term solution. It normally involves fairly extensive investigation, so you need to actually do lots of testing to determine which areas of your structure are contaminated and to what depth they're contaminated to, and then you would need to actually chip out all of that contaminated concrete and place it back with fresh concrete. So as you can imagine, it could be it's a fairly intrusive repair, which can end up being fairly costly. and take a lot of time. I added this photograph in the bottom actually. So, you can just imagine this is a photograph I've taken actually for a tower in Dubai where we were doing an inspection of the parking garage. I mean, you can just imagine asking the owners of these cars if they mind parking on the street for 3 months whilst you remove all the contaminated concrete. So another solution could be, surface sealers. So surface sealers generally will stop more chlorides from getting into the structure. They probably won't block oxygen or carbon dioxide, and they definitely don't address existing contaminants. So it means that, the steel, if it's already contaminated, will definitely continue to corrode. A better solution for corrosion control can be high-performance membranes. So if you have a high-performance membrane on your structure, yes, it can prevent chlorides and carbonation from getting in. It can prevent water from getting in, but it doesn't address existing contaminants. So this is where it's actually really important to maintain coating. So a lot of the buildings we work on in Dubai are actually less than 10 years old. And we go into them and we see the car park coatings have deteriorated. So if you have a new structure, then it's always good to maintain these protective coatings to prevent that contamination from occurring. Because once the contamination occurs, then it's very challenging to address it. So even if you put a high performance membrane on it, then it can do two things. For an elevated slab, it will prevent oxygen from getting in, so that would slow down corrosion. If you have a slab on grade, then actually the membrane will actually prevent moisture from evaporating. So that means the slab will actually become more saturated, which again will reduce the availability of oxygen. So it will reduce the rate of corrosion. So membranes can be used to extend, to kick the can down the road, if you like. So they can be used as short-term solutions to reduce corrosion, but not necessarily mitigate corrosion. So a technique which can be used to mitigate corrosion is something called cathodic protection. So cathodic protection is an electrochemical technique used for corrosion control. So in simple terms, corrosion is the process of energy being released from the steel. And cathodic protection is a process of putting energy back into the steel. So there's two main types of cathodic protection systems. The first is a galvanic system. So galvanic system, the main feature is that they do not require a constant source of power. So they actually use the natural potential difference between the anode and the cathode. So the anode may be zinc, the cathode is the steel we're trying to protect. We use that natural potential difference to provide the the protective current. For an impressed current cathodic protection system, then we require an external power supply. So I'm just going to show you a couple of different examples of cathodic protection systems. So there's lots of different systems available, and they're generally selected, based on the geometry. So, what is the area of the structure you want to protect? Is it used as a driveway? Are you protecting isolated columns? Are you protecting just some high-risk areas near expansion joints? Or do you need blanket protection for your entire basement? So the range goes all the way from discrete galvanic anodes up to state-of-the-art impressed current cathodic protection systems. So system which I really like, we've installed a lot of these across the UAE recently, and this is called the Easy Anode zinc panel system. So in simple terms, if you look at the diagram on the right or the schematic, what we do is we have we surface prep the concrete. We make a breakout so that we can make a connection to the steel. The zinc mesh is attached, the zinc mesh is attached to the concrete member, and then it's encapsulated in its proprietary geopolymer. A connecting wire is made between the zinc mesh and the reinforcement, and that enables the protective current to flow from the zinc through the electrolyte, which is the concrete, to the steel, causes a reaction to occur at the steel, which provides protection. So this type of system provides, typically 15 to 20 years of protection. One of the big advantages is that it's very good for protecting discrete elements, and there is very limited operation and maintenance. So it's like an automatic self-regulating type system. Somewhere we install a lot is for expansion joints. So for example, if you have a retaining wall in a basement with expansion joints, typically if those expansion joints have been leaking between 3 to 5 meters either side of the expansion joint, there will be a high risk of corrosion. So they're the areas which require protection. And this kind of reiterates what we talked about yesterday, or what was talked about yesterday by Morty. And that is, really providing optimized solutions. So if your basement wall is not 100% at risk of corrosion and you only have a risk near the expansion joints, then you only need to invest money in protecting near to the expansion joints. And that's where this system really does have, can provide good benefits. Another system, which is also galvanic, so there's no power supply, typically life, up to around about 15 years. So this is called metallizing. So metallizing is where molten zinc is actually sprayed by using compressed air onto the surface of the wall. So we'd start the installation by installing a metal plate onto the wall, which is connected to the steel. So that becomes your negative connection. You would then, shot blast the wall, and then it's sprayed with this, probably up to about 200 microns of zinc, which can then be covered with, an acrylic aesthetic paint if required. So this system is really nice because it provides a good length of protection, like I said, about 15 years, and very, very little operation and maintenance. Other systems which can be installed are impressed current systems. So these generally, there's lots of different anodes out there. One of the most common types would be a mixed metal oxide coated titanium, which could be installed as a ribbon mesh, which is installed in saw cuts or slot saw cut into concrete cover, or it could be discrete anodes installed in drilled holes, or it could be, an expanded mesh, looks a bit like a chicken wire, installed across the entire surface, encapsulated in a cementitious overlay. So generally, if you're looking to protect large areas, especially if it's, horizontal slabs, driveways, then ICCP is a very economical way to provide, up to 50 years of corrosion control. So this last section is going to look at strengthening. So we're going to particularly focus on one area of strengthening, and that's requirement to strengthen slabs due to, which have failed as a result of hydrostatic pressure. So typically, basement B1 to B4 basements are common across the UAE. We've seen, I think the deepest one is maybe has 6 or even 7 levels, but basement 1 to basement 4 is extremely common. Everyone probably knows the groundwater table here is very high. So if you actually excavate the soil around the building, probably 1.5 meters, you would reach the water table, which means that you have a very large, hydrostatic pressure, which could range from 10 to 160 kPa. So what this does is, so this represents a diagram where you can see this is the slab and pile caps. So this would represent the lowest level of a basement. So this huge hydrostatic pressure can cause the slab to bend, which can provide or can result in flexural failure or shear failure between the connection between the raft and the pile cap, can cause a lot of excessive cracking, which can result in durability related problems, and of course ultimately failure of the raft. Often where you have uplift problems, you also have huge problems with groundwater ingress. So once you bring in these, once the slab bends, damages the membrane, you bring in all these cracks into the structure, so it's perfect for groundwater to come up into your structure. So if you're an owner, what to look out for to see if you think you may have a an uplift problem. So a very common observation would be water seepage from around columns. So you can see a couple of photographs here as a moderate example on the left and a very very severe example in the middle. Sometimes you can see the bulging of the slabs with the naked eye. Sometimes if you just have a gut feel it might be there, then you would need to, obviously if you engage a qualified professional, they may come in and do a level survey, and then you would get a clear understanding of where you have this undulation. You may see excessive cracking in the slab, and you may see, delamination where there's no corrosion. And of course, probably anything other than water seepage around columns would only be identified by a licensed design professional. So you bring in maybe you think you have a problem, and then you bring in an expert, and they will determine whether you have an uplift problem or not. In terms of the solution, generally it includes installation of a reinforced structurally bonded overlay and removal of any heavily damaged or fractured concrete. So this is a simple diagram here. So you can see that what we're doing is we're actually increasing the thickness of the slab. So typically you would install a structurally bonded overlay of between 100 to 350 millimeters on top of the existing slab. One of the biggest challenges with this type of repair is actually consideration to the headroom. So often there's MEPs, ventilation systems, firefighting systems installed on the soffits. So you need to make sure that you still adhere to the municipality requirements in terms of headroom. So steps for this repair, this is very simplified, but you require correct surface profile on the existing structure or the native concrete. So that's generally CSP 6. I just need a 6 millimeter amplitude. You would then install the new steel reinforcement because it's a reinforced bonded overlay. You would need to install dowels to make sure you have correct shear transfer. And then you would want, like we discussed before, about having an open pore substrate. So you need to make sure that the existing structure is super clean. All the pores are open, so that then once you pour the concrete, you can get this monolithic composite action. So you would probably vibrate the concrete to make sure that you get that, the repair material into the pores of the existing structure. So this kind of concludes the seminar today. So hopefully it's been interesting. Like we said at the start, it covers 4 fairly extensive, detailed subjects. So we welcome you to contact us afterwards if you require any further information. But just to summarize, what we discussed really is that there's the repair process should be followed. So that definitely starts with investigation. When it comes to the engineering, there's always lots of different solutions available. So it's important to make sure that your engineer is discussing with you as an owner to ensure that your objectives are fulfilled. And of course, then the last part is construction, which to make sure you have durable, long-lasting repairs, you need to be engaging a specialist repair contractor. Of course, importance of QA/QC and use of qualified experts to avoid early failure of repairs. So this is, we're talking about best value. So every dirham is extremely important. So whatever you're investing into your building as an owner, you deserve the best value for that. So how do you get best value? And that's making sure that you have correct QA/QC and ensuring that you have qualified experts repairing your structure. So it's been mentioned a couple of times, but one thing we actually provide, and you can see on the right-hand side, this is one page for our basement inspection checklist. So actually, the service that we provide for free to owners is a complimentary inspection of your basement. So one of our experts will come out. They will inspect all of the levels of your basement. We have a 5 or 6 page report, which would then be issued to you, and that can be used to help you determine what would be the next step in terms of your repair process. So I'll say thank you very much for your time. I'll hand back to Karam, and I think we're going to do some questions next.
Thank you, Bill. Thank you for the information. And before we actually get into the questions, I just wanted to remind everyone, if you could please just take a couple of minutes to fill out the survey that will pop up. This will truly help us. Bill, I've seen a couple of interesting questions that I'm going to be clubbing some of them together because they're all related. But first question talks about or asks, where you showed that diagram where if you have a corroded reinforcement, you have to keep on chasing the reinforcement, right?
Yep.
So for sometimes for old structures, it's this process. I mean, it's very extensive. So is this the only way? I mean, is this something that you always have to do, or is there any other thing that you can do? And there's another question that also talks. Maybe you can address that at the same time about: is there any kind of equipment that you can actually use to detect if the rebar is already corroded without doing the chipping works?
Yes, so that's two very good questions. And actually, so, because if you keep chipping and you keep chipping and you keep chipping, eventually you may get, the corrosion may not stop. And we've actually faced that on some of our projects where we keep chipping and we say to the owner, we're still finding corrosion, or the engineer, he says, keep chipping. And eventually you have to make a decision, what to do. So at that point, you would maybe have, you could look for other techniques. So for example, you could install cathodic protection. Doesn't have to be a complex impressed current system. It could be a more passive galvanic system. But if you provide cathodic protection or other means of corrosion control, then it's not necessary to keep on to keep on chasing the corrosion, because you can actually have other technologies which can be used for corrosion control. So hopefully that answers the first question. And then the second question was techniques to understand if you can find out, is there any equipment available to find out if corrosion activity is occurring? So yes, absolutely there is. And that kind of falls into the investigation and condition assessment, which was discussed yesterday. So examples of non-destructive techniques which can be used. So you can do half cell potentials, which will help you understand what the risk of corrosion is. You can use linear polarization resistance to actually measure if there is any active corrosion activity. Also, you can use some scanning techniques. So GPR, ground penetrating radar, or UPE, ultrasonic pulse echo, can also be used to see if you have a severely corroding bar where there's a lot of corrosion product built up, then you can sometimes see them with these scanning equipment as well. So definitely there are lots of non-destructive or semi-destructive techniques which can be used to help determine if you have a corrosion problem, without necessarily breaking out and exposing the steel.
The next question, actually, again, these are two questions. I think you can address both of them. So the first one says that they are actually using some sort of an epoxy coated reinforcement. Does the epoxy coated rebar still corrode? And another question that is, I think, somehow associated to it is, what is the role of corrosion inhibitor coatings on reinforcements? So do they help? What is your information or experience tells you about them?
Sure. So answer the first one. So first is about epoxy coated rebar. So the way that someone explained this to me recently, actually, I think it's a good visualization of how to understand it. So in the factory, the rebar is made and it's coated with an epoxy coating. So at that point, the rebar is probably 100% covered by its protective epoxy coating. So that means that the epoxy coating is providing some corrosion protection to the steel. What happens then is they take these 20 bars, they bundle them together, it's lifted up with a pickup, it's taken over, it's dropped on a lorry, more of these bundles are added on, it goes to the construction site, it's taken off the lorry with a pickup, it's dropped on the floor, the guy picks up one end of the bar, drags it along the floor, takes it to his machine, puts it in a bender, bends it. So you can imagine, you can picture by the end of this process, your bar is not 100% covered in epoxy anymore. It's going to have pinhole defects. So wherever you have those pinhole defects, you can get corrosion. Corrosion will occur. And then what can also happen is that the corrosion product can then extend underneath the coating. So by all means, certainly from my personal opinion is that epoxy coated rebar doesn't necessarily result in a structure with increased durability. And then the next question was related to corrosion inhibitors, right?
Yep.
So I don't know whether, the context of the question, I don't know the exact text of the question, but there's different types of corrosion inhibitors which are available. So, some of them are applied to the steel directly. So I know some companies have some rust converters, for example. So it's some kind of, chemistry which can be used to actually remove rust on steel and provide corrosion protection. So yeah, I think where you have corrosion inhibitors or corrosion inhibiting materials actually applied directly onto the steel or added into the concrete as an admixture, then I think that there is good track record and it's reliable technology. So I don't know if that answers the question.
Yeah. So another question actually talks about the easy anode. So you've talked about the easy anodes, and the question says, how's the effect of performance on easy anodes and coatings if they get damaged after installation?
If the okay, so they're talking about you install an easy anode on a column and you coat the column and the coating gets damaged, right?
Yep.
So actually, if I understand the question right, the coating is there just to provide aesthetic finish. So actually the coating isn't a part of the aesthetic coating is not a part of the system. So that would be optional. So the system would continue to work with or without a coating, and even if the coating is damaged. If they're talking about the actual geopolymer which is used to encapsulate the anode, then that's I can't think of the compressive strength of it off the top of my head, but that's actually a strong material, so it can resist fairly high mechanical impact. So it's very unlikely that the actual geopolymer would become damaged. But if they're talking about the aesthetic coating, then it wouldn't have any adverse effects on the performance of the system.
All right. What about the ICCP? There's another question that talks about the ICCP in general, and what is the recommended type of membrane? Is it cementitious based or epoxy based?
Over the top. So it's definitely not epoxy based. And the main requirement for the membrane is that it has to be breathable. And that's because you can get gas, although small amounts, you can get gases produced. So you can get gases produced at the anode, and these gases need to be able to be released through the coating. So if you have an ICCP system and you install a epoxy coating on top, especially where you have moisture involved, then there is a possibility that you can actually end up with blisters occurring in the coating. So definitely breathable properties are required, and I know a lot of manufacturers actually, the big chemical manufacturers, they actually have coating systems which have been extensively tested, or membrane systems which have been extensively tested with cathodic protection. So there's companies out there who can provide coating systems which are actually tested to be compatible with cathodic protection.
Okay, another question talks about, when you talked about the injection techniques of cracks, maybe it was missed, but they're asking if you have a thick raft, for example, and you have a crack that is going deep inside the rafts. How can you make sure that you're actually injecting the full depth of the crack? Can you elaborate more?
Yeah, that's a good question. We didn't really talk about QA/QC on cracks. But yeah, one way to ensure that you have, say if you have a raft which is 800 millimeters thick, and we're talking about you've got a through and through crack, where you've got water, groundwater coming through. So one way is ensuring you just have a good technique. So that would be, if you're doing interception grouting, then you need to make sure that, your drill hole is positioned in the right place, you're drilled at sufficient angle. Because then if you intercept the middle of the joint, you have a better possibility or better chance of sealing the entire crack. Something else that you can do is, it's sometimes difficult, but you can monitor material consumption. So you would have an estimate of how much material is going to be used, and you should make sure that you're in line with that kind of estimation. If you're not, then you would do some investigation to see why you're not in line with it. Probably you wouldn't do it as much for a raft, but if you're doing it for a a slab, for example, if you have a thinner slab, then you can actually take representative cores. So if you do 100 linear meters of cracks, then maybe you take 2 or 3 cores, so you can actually remove a core through the crack, and you can check whether it is completely sealed. Or you can also use non-destructive techniques such as UPV, for example, so ultrasonic pulse velocity. So you can use ultrasonic techniques which can be used to determine whether a crack has been completely sealed or not. So I would say that it's a combination. You have to use a combination of techniques, and obviously the thicker the element, then probably the more challenging it becomes to get that 100% certainty. But I think that there's a lot of technology out there you can do, which you can use along with correct means and methods and correct QA/QC to ensure that you get that full crack sealed.
All right. Another question says, if you had an existing member with corroded reinforcement, so let's say that's the solution included to chip out the concrete, clean the reinforcement, and then put some corrosion inhibitor on the steel, and then you also, or the client also had put some kind of a CP system. Will the CP system have any interaction with the corrosion inhibitor that was put there, or like how are they compatible together, basically?
So they can be compatible and they cannot be compatible. So you'd have to determine it on a case-by-case basis. Generally, where you have incompatibility is more between galvanic systems. So if, for example, you have a corrosion inhibitor in the concrete and you have a galvanic system is working by, if it's an anode which is embedded, the anode is working by corroding. So the inhibitors may actually prevent the anode from working, so they may shut the anode down. Also, I know of a study which was done where they tested, this is not for a basement, but it was for a different type of structure, where they tested a compatibility between a corrosion inhibitor and an ICCP system. And they were actually, in a way, although they were providing, both of them were providing protection independently, actually by installing the corrosion inhibitor, that was working as a cathodic depolarizer. So it meant that you actually needed to increase the capacity of the cathodic protection system to overcome the depolarization which was being provided by the corrosion inhibitor. So I mean, it's an extremely complex question, but I think it has to be looked at on a case by case basis. But the answer is, sometimes they're not compatible, sometimes they are. But it's a great question, and what everyone should remember is that all of your systems that you're using, you need to check that they are all compatible, whether it's corrosion inhibitor with CP or whether it's CP with a coating. It's really important to make sure that all of the materials you're using in a repair are compatible with each other and work well together. So I think that's a really good question.
Yeah, I think it also addresses some of the times where you have a structural issue and also a durability issue in a basement, in which you always have to also make sure that the strengthening solution of the structural issue is compatible with the waterproofing solution. So, because there's a question also that discusses this, so maybe it'll have the same answer. So another question says that you have talked about a lot of different repair techniques. But the question says that based on your experience, or do you think that if you actually had a good QA and QC program during the construction, will this better help to protect the overall asset or structure? Basically, like a mixed design, test samples in the lab, checking when setting up is and all that stuff.
Yeah, 100%. No, I think I mentioned it in the presentation. A lot of our structures that we repair are less than 10 years old. And these are structures that have been designed with 50 years service life. So if you have a structure which was designed with a 50-year service life and it's failing fairly extensively at 5 years or 8 years, then it shows that something went wrong. So I think definitely if you can have increased supervision during construction phase, and I think it's also, it touched, I guess, on it yesterday, and it's bringing in the right specialist supervision. So, for example, if you take the waterproof, if you take the membrane, on a building, from our experience, most of them leak, don't they? Some way or another. Now, probably it's a good quality product. Probably the design is good. Maybe there's some challenges with installation. If you, for example, engaged a specialist, membrane consultant at that time to come and help improve the quality on your site, then for sure, I think it would end up with a net positive effect. The same as with the concrete mix. So again, linking it to what we saw yesterday, I know that Simco and Stadium can help, design concrete mixes, which can even, provide 100 years service life for a structure. So I know on some of their projects in Canada, what they do is to ensure to increase the possibility of that service life being achieved, as well as doing the design. They also provide supervision on site. So I think, the more specialist supervision you have involved earlier on in the project can only be a benefit.
Okay, and one more thing, when you talked about the positive side and negative side waterproofing solutions, one of the things that this question talks about is the GRP lining. So is it considered to be a good waterproofing solution or secondary line of defense, or what is your take on the GRP lining?
Yeah, I think so. I think it's a well tried and tested technology. It's used a lot on a lot of water tanks. We see it also on cooling tower basins, for example. Where you can end up getting failure is usually it's failure between the GRP lining and the substrate, and obviously it's a brittle material. But yeah, I think as a system, providing it's designed and installed correctly, then yeah, it provides a good positive side system.
All right. The last question also says about for cathodic protection systems, is there any required really yearly basis testing plan or something like that, or?
Yeah, I mean, if you go back to the code, so the British code, which is 12696, or there is the NACE codes, then they all recommend some kind of maintenance or monitoring and maintenance routine. So and that's one of the advantages really of a galvanic system, is that with a galvanic system, the level of maintenance or inspection is significantly reduced compared to an impressed current system. I know there is, that's kind of one of the pushbacks from the market generally, is the kind of misconception that there's a lot of operation and maintenance with, for example, an ICCP system. And actually, if you look at the cost of that operation and maintenance, it's actually a very, tiny amount. And that's why, sometimes on our projects, we actually will provide to the owner at the time of supplying the system, we'll actually provide 10 years operation and maintenance in with our original price. So it means it gives the owner peace of mind that system will be maintained and operated correctly over a 10-year period without them absorbing any additional cost.
It's interesting. Thanks, Bill. I want to one more time thank everyone for joining us, and I just want to remind you again, if you haven't registered for tomorrow's webinar, tomorrow we have a webinar that will be continuation of what Bill has discussed today. I want to remind you all to register. We hope to see you all there. We truly appreciate your time and the feedback. Have a good day. Thank you.
Thank you very much, everyone. Bye-bye.